As everyone knows, hot bodies emit electromagnetic radiation, such as infrared or visible light. The ability of a body to produce thermal radiation with a certain wavelength is related to its ability to absorb radiation with the same wavelength. The higher it absorbs, the higher it radiates at the same wavelength. A body which totally absorbs all rays incident on its surface, at any wavelength, at any angle of incidence, looks ideally black, so that it can be called the perfect black body.
So in the limit, when it is perfectly black, it is called perfectly black body, and in this case, reflection will be eliminated. So no energy lost here, and all the rays which enter the body are completely absorbed and harvested. But still, rays which we don't touch the body obviously go away.
When such a body is heated up to a high temperature, it emits radiation with well-defined spectrum, determined by the famous Planck's radiation law. Due to the fact that the perfect black body is perfectly black, it is tempting to believe that such body is the best absorber ever, and therefore it's also the best thermal emitter, as compared to all other bodies with the same size and shape. In many textbooks on thermal radiation you will find such statements.
It's interesting, however, that if you consider a small object, let's take a small resonant antenna, like piece of wire, load in form of a resistor to absorb power, and then some reactance to tune it to resonance, and the size is now very small compared to the wavelength. But the antenna is resonant. Then, of course, rays which enter and hit the antenna straight get absorbed, because it is matched. But in addition, it will in fact attract energy from a wider area this way. So some nearby passing rays will actually turn like this and still end up delivering power to the resistor over here. And the area from which it harvests energy is of the size comparable to wavelength, so it's about lambda. So this small object, because it's resonant, is doing better than the perfectly black body.
Similarly, if one could realize a macroscopic object which would intercept the incident rays from an effective area much larger than its own area, such an object would be a much better absorber and therefore a much better thermal emitter than the perfect black body. In this article we show that realizing such an object is indeed physically possible. We also prove that there is no upper limit on the spectral density of thermal radiation produced by a hot macroscopic body.
So that sounds exciting, but is it possible at all? So is it not against thermodynamics? And if it is possible, then, well, how are you going to do it? So what kind of material you will use to produce this infinitely black material? And these are the questions which you answer in our paper. Thank you.